Welcome to Fully Charged. Today we are in Michigan on an incredibly sunny day at the University of Michigan and specifically MCity Autonomous Vehicle Test Center. It's a little bit of a cross between Disneyland Autopia and SimCity. It has an invisible train and even the lawnmowers are autonomous vehicles here. Come along while we check it all out.
It's great to have you here. We're in our test facility.
Yeah.
So MCity is a public-private partnership between mobility or transportation industry companies, the University of Michigan research communities across the whole breadth of them, right? Law, public policy, engineering, all that, and government. And we bring all of those companies and groups here together to jointly look at bringing advanced technologies like connected systems or just self-driving cars and things like that to society in a thoughtful way, hopefully, in a beneficial way. So we're running right now in one of our member companies, Navia's shuttle. They've come here and we're studying kind of everything from how we could test a system like this before then it's out on the public roads, to seating configuration choices and all that sort of thing.
Where do you pick to sit and
exactly.
does it make you motion sick in the process?
Do you get motion sick? Exactly. All of that research data then comes together and is available for all of these companies to use. And that's the real value. They're working on these problems together.
Right. Yeah, it's very topical. You get to play with all the companies but be agnostic to any of their business cases per se.
Exactly.
And just mostly study the topics versus the business side and the politics.
Yeah, that's their job,
right?
Right. So I say pre-competitive, we're kind of trying to stay one step ahead. We work with a lot of other universities. It's not just a University of Michigan thing.
Of course, yeah. Well, that's what's fun about it for those of us on the outside, is it's not so proprietary, not all about us, and it's very much let's be rising tide from an intellectual standpoint.
Yeah, I think if these technologies are going to come to society in a way that's really beneficial and usable for us, it needs a lot of research into how that can happen. And in a whole variety of areas. What are the ethics around sharing data?
Where does liability go?
Precisely, yes.
Insurance companies don't want.
Insurance companies, we have State Farm as a member here looking at those kinds of questions. Public policy, how our cities should or shouldn't change to accommodate. There's a whole variety of topics, and that's the interesting thing about working here and working with 60 companies all together.
Yeah, the complexity is the most fun.
Yeah, exactly.
So you're going to show me a Lincoln next?
Let's take a look at the Lincoln. This is one of our research vehicles, Lincoln MKZ. It's been kind of retrofit to be a level 4 AV.
Okay.
And I'll show you some of the things that we're working on with it to demonstrate and support our research here. Sitting in is kind of meant to be an open platform for research.
We're just waiting for the light to turn green.
Okay, and I am not actually
And there's no touch, Look, no hands.
Exactly, So these are students and postdocs who built all this. So we use it for all kinds of different things. Obviously we can demonstrate connected and automated capabilities here today, which I think is really fun. So it can look at, this car can see the phase of the traffic lights, right? But it can also receive them over a wireless technology. So if there's a big truck or something in front of us, it doesn't need line of sight to the lights to know, oh, there's 7 more seconds on this phase. Now, the fun part about this lab is you can reconfigure the signage kind of as you want, right?
Yeah.
Everything's on quick release. Here we've set up kind of a blind curve, right? What's around here? Is there a cyclist? Is there a parked car, maybe? And you can test the ability of your sensors to see around that corner, or maybe the ability of your connected systems to warn you that there's a stalled car.
You talk about DSRC communicating with the car and sort of the infrastructure and all that, and there's these sort of 5G versus DSRC versus whatever else debates, like VHS and beta.
Right.
Are there certain things that each one is better at, or do they both overlap? That either could be used interchangeably?
Yeah, that's a great question. I think there are certain things that each one is better at. I think that the thing that I get into is, I'd like to see these things out there now.
Right.
DSRC is based on a Wi-Fi kind of standard 802.11.p, which most of us have not ever used, except in this facility. We also have 70 intersections out in Ann Arbor in the city, though, that are broadcasting over DSRC. And we have 20 500 vehicles that are out running around with that right now, as probably the largest deployment that there is. I think maybe we're getting eclipsed now by a few additional DOT deployments, which is pretty exciting. I'm glad to see that actually out there. 5G, I think, has a lot of promise. It's a really pretty brand new technology.
Right. There's a lot of hype around it at
There
a minimum.
It's a grab bag of different standards too, so I think there's some confusion around what all is in. When I say 5G, does that mean the same thing?
What does it mean for my phone versus potentially for my car?
AT&T, branded their 5G, 5GE.
Yeah.
But I think it's really like next generation LTE. So there's whereas Verizon has got Verizon's one of our member companies, full disclosure.
Right.
Who's been fabulous to work with. They've put a whole 5G system in here that is the millimeter wave 28 gigahertz system, and that promises a lot more bandwidth. But I think for automotive and for safety, an interesting aspect is a lot lower latency. So the time it takes, the delay in sending
quicker
my
responses
message,
and stuff,
is much less. On the order, I think, of around 10 milliseconds kinds of times where, if you're broadcasting like DSRC basic safety message, which is a standard, there's a SAE standard for it that sits on top. We're broadcasting kind of position of the vehicle 10 times a second. Well, that's 100 milliseconds. So, and that's sufficient even at highway speeds to ostensibly to avoid crash.
Is the promise of 5G more about communicating with other moving objects?
Yeah.
And more variable things versus a street light that never moves? Is that part of the advantage that's hoped for, or
I think
does it matter?
They're putting a lot of things into 5G. So I think one of the things is to be able to talk to a whole lot of devices in a small area.
Yeah.
Maybe I don't need physical connection to traffic lights or to street lights or things like that.
Right.
They can be communicating all on this network, and I can actually support that density.
Yep.
So I think that's a big piece of the 5G promise.
Yeah, so on the screen there's cars doing sort of deviant
crazy
things.
Behavior, right? Like we're trying to swerve in here. Oh.
Right, someone trying to cut us off,
cut us
sneak
off,
by.
let us in. So you can kind of see the crazy way this vehicle is trying to avoid it. Yeah, it does look a little weird when you're outside and it's just randomly
just
swerving
like,
to
what the
avoid.
heck is going on here? The car's drunk.
Yeah, what I love about this, is it really lets us set up kind of complex tests, and we can do them with a high degree of safety, which is really important.
Yes, well, and repeatability.
And repeatability, absolutely. If you start to look at and we've got several research projects around this. One is called our ABC tests. How do we test that an AV is really competent to go out on the roads? I think every company kind of has their own set of tests about that, but it's not out in the public knowledge of how they're doing that and what they're doing. But what kinds of tests can we give to an AV to actually understand, so in this operating domain, you are reasonably safe to continue, testing now out on the public roads, and not, without danger. And I think that's an important example of the research that we are doing here.
Well, and I would imagine, for a variety of reasons, the desire for objective testing of various systems against each other. Like, what does ProPilot for Nissan mean versus Super Cruise versus Tesla Autopilot, and on and on, especially from a consumer that's trying to figure out what they want and need once there are more options.
Yeah, I absolutely. You want to be, in the same way that we have sort of IHS crash test results. I think we want to have, some other neutral way of saying, like, well, we tested these kinds of AV systems and they work under these conditions and that sort of thing. This facility is really designed to test the brains of a vehicle, where I think current facilities are designed to test
mostly the brawn.
Exactly, the muscles and bones. This one is really all about the brains.
What else are you seeing kind of come up and that folks wouldn't necessarily be expecting if they weren't AV engineers in the space?
Yeah, so I think motion sickness is a great one, right? Because it's not something that we think about. A lot of people want to be the driver,
right?
Because it helps them avoid motion sickness. So, what happens in an era then where there are fewer drivers, or you're not spending as much time driving? And so, how do we talk about motion sickness? How do we measure it? How do we know that any sort of mitigation efforts are successful? We need to have a way to quantify it.
This experiment.
Absolutely. We have been concerned about the incidence in motion sickness in autonomous vehicles.
Right.
So as drivers transform to passengers, we're concerned that there's going to be a higher prevalence of it. And so when we looked at the literature to develop testing on it, we realized that a lot of the studies have been done in simulators, driving simulators, and in motion platforms, but not a lot have been done in actual vehicles.
Sure, yeah, absolutely.
And so the goal was really to develop a repeatable protocol that we could quantify, because if you do a quick Google patent search on this, you'll see that there are all kinds of mitigation strategies popping up right now, right? And it gives you a sense that the etiology or the causes of motion sickness maybe aren't as understood as we think they might be at this point, just because the variety of approaches on how to mitigate are so varied.
Right.
So we wanted to develop a protocol that we could start quantifying, and for diverse populations of people too, because people who will be driving the vehicles will be very highly ranged, and we want to make sure that whatever solutions we develop will work for all passengers in future vehicles.
Yeah, because there's a huge enthusiasm for the potential for autonomous vehicles to create more mobility for elderly and disabled and a variety of other populations.
Exactly, especially some of those vulnerable populations that aren't currently served by current passenger vehicles. Yeah.
And kids, for that matter.
Frightening, but true.
I know.
Yeah, exactly. And so then when we looked at, well, how do you quantify motion sickness, it became readily apparent that a lot of the scales were focused on nausea and vomiting. But when you're thinking about how you want to drive in an autonomous vehicle, I mean, obviously we'd miss the continuum.
You don't want to be vomiting, for one thing.
No, if you can't use your time as you want to or intend to, then maybe we've missed the mark.
Right.
So we wanted to create some new scales and new protocols to ensure that we were really capturing what it was that people were experiencing. So we created a new scale that enabled people to just exercise it as I feel fine to stop the car.
Right.
And of course, how that manifested can be very different from one person to the next. And then we also have people self-report in their own words, just narrate the entire time what it is that they're experiencing.
Yeah, I'm good, or oh my God, I'm gonna puke. Pull over now.
Exactly. Stop
Get out
the car.
bag.
Get the emesis bag. I'm gonna need it now. Exactly. But then we also want to tie that back to, I mean, if you can imagine sensors in a car, we want to be able to predict when occupants are getting there. So sensor-free type, where we're not putting sensors on the person.
Yes.
Quantify when people are their symptoms are escalating. So we have continuous objective measures that go with that. So physiological measures. We've got the different cameras that are measuring where your head is and where your torso is in space. Your heart rate.
So you're moving around too much.
Right.
And you're looking for that sort of thing.
Exactly. So is someone who's a non-responder versus someone who's a high responder, is there something different about the way, in particular, maybe their head motion relative to their torso, or maybe they're slightly more unstable, or is it that they can anticipate the vehicle motion, for example, and so they're tilting their head in a certain way that may prevent how they're feeling? Are you susceptible? Would you consider yourself?
I had it when I was a kid. I would get reading in the back of the car. I'd get motion sick. It's less of a thing now, and I spend a fair amount of time on my phone and whatever as a passenger.
Traveling.
So I don't think I am particularly susceptible, but you know, self-awareness is not always anyone's strong suit.
So true, isn't it? I know, reflection on ourselves.
Yeah.
Right. Yeah, and I think it does change over, we're seeing an age effect, definitely. Older drivers are experiencing different sensations, and then it's a dampened but a longer effect.
Yeah.
We also follow people through recovery.
Yeah.
So once they get out of the vehicle, we track how long it takes for those sensations to decay as well. And I think from an older person's perspective, we could be creating some effects that have long-term. So one of the things we do is measure balance, for example, because that will be a function of, is the vestibular system
for sure
affected, right? So we have them stand in a clinical measure where they're swaying. They have to stand on a piece of foam and measure that to see if there's been an increase in sway, and definitely that's persisting.
And I was thinking even similarly, not vestibular, but sort of a core strength issue. Like as you lose that core strength, you keep yourself less centered in an intuitive way.
Inherently, you do have an increase in sway, And then by being in the vehicle, with the addition of running the task, you're seeing that there's even more of an increase in that sway after the fact, especially with the older adults.
Looking at the role that connected systems can play in an automated world, right now, to get to that human level of safety, to be honest, I know we say, oh, humans, we're terrible drivers, and we do, it's true, we cause a tremendous amount of carnage on our roads, but if you look at the amount of miles that we drive between sort of major problems or fatalities, it's about 100 million right now in the US. I would argue we're going to want socially, we're going to probably want maybe an order of magnitude improvement over humans. So that means 1 billion vehicle miles between any sort of fatality. And I think that's a really hard and high bar.
Yeah.
And so any sort of technologies that we can put in place to help us get there will be needed. And connected systems then are one of those that kind of helps get another layer of redundancy of information to a vehicle or to other actors in the system.
Right. Yeah, because we sort of accept 100 deaths a day or whatever it is by humans in the US at least.
Right.
But if computers kill 30 a day, that's unacceptable.
Right.
It's this weird double standard.
Well, and it is a sort of moral quandary where, I think, Mark Rosekind always says sort of who has the moral authority to kill people in the development of these technologies. And I accept that. I think that's
it's a fair question at least.
It is. And so, I as an engineer, of course, want the fatalities to be zero. So that really should be our goal.
So we've had a really fun day here at MCity. We've nerded out on all sorts of autonomous vehicle things, the opportunities, the challenges, the technologies, and why in order for them to ultimately work, some people are going to have to puke along the way. Thanks for joining us on Fully Charged, and we'll see you next time.